Thank you for viewing this presentation by Radiation Oncology Resources. This presentation focuses on a benchmarking program that we are calling ROQS. This is a follow-up presentation to a live webinar that we ran recently. Essentially, ROQS is a benchmarking program for treatment planning and contouring. One of the questions we commonly get is, are there MDCB credits associated with this presentation? Obviously, with this web-hosted one, there is not. But we do have some exciting news about MDCB credits that are associated with the ROQS program at the end of this, or towards the end of this presentation. If you have any questions about the content of this dialogue, you can contact us through any of our social media outlets. We'd be happy to answer any questions that you have. If you're familiar with any of the projects that ROR has been involved with, the Plan Challenge Research, the Contouring Challenge Research, you know that one of the points of discussion that we focus a lot on is this idea of variability. And that's an important element of this ROQS program, is the attempt at minimizing variability in those key elements of designing a treatment plan. Now, it's hard to talk about a quality improvement program for treatment planning without looking at the overall planning process. Of course, we have our contouring, both for targets and for critical structures, setting the beams, optimizing, calculating, and then ultimately doing the plan review of the dose distribution and the DVH. By incorporating elements of a healthy quality system in this process, driven by objective software, we believe the future of the planning process can look a little bit like this, where we're incorporating through our EMR systems. You notice that there's a performance tracking, and one of the key ingredients to the ROQS program is using software to objectively quantify plan quality. We'll talk a little bit about what that software is towards the end of this presentation as well. But when you look at the planning process of the future, we'll have the ability, by collecting useful data and objectively looking at plan quality, it will allow us to really go down the path of defining best practices and developing a continual improvement program. Through this data, we'll also be able to do true cost analysis and have an improved method for running our current clinical trials. ROR and our new mission has definitely evolved from just providing dosimetry services. Even though we've done that for several years, both on-site and online, we're really looking for ways to assess variability, develop opportunities for partnering with our peers, and provide mechanisms or services for continual improvement. And that's the theme of this presentation and our ROQS program. So let's look at the mechanics of the ROQS program a little bit. In a nutshell, it operates something like this, where we would bring in a plan, objectively look at it, score it with what we call a PQM score, and then with that score we're able to do a comparison with a population of people that have gone through the same set of parameters, adding those values to what we would say is a bucket of best practices. And we really built the program to be an affordable, convenient, that is web-based way that can be completely customized to what your in-state goals are. Even if you're not looking for improvement per se, this program could really provide a documented validation of where you currently stand. So there's a little bit in this program for everyone, including the benefits of MDCB credits, and we'll go into a little bit greater detail on that shortly. So why did we develop this program? When you look at benchmarking plan quality, some would say that's a very subjective thing. The beauty of a plan could really be in the eye of the beholder. When we're looking at this dose distribution, how do we know as a community we're all, based on the same set of parameters, doing things in the same way? And it's really what's inspired to build this ROQS program. We're proud of, or I'm proud of, not only the efforts of all of my ROR colleagues, but also proud of the fact that this program has really been built with the involvement of all of you to help bring it to life. We've had the opportunity to work with professional treatment planners all over the world really the last several years, and we'd like to think that we've captured that expertise and synthesized the information into our ROQS program. So some of the challenges we currently face, as well as on a larger scale, we just recently gave a presentation in Boston at the SROA meeting to administrators, and the four key elements that we focused on was talking about maximizing safety, improving quality, but on a much smaller budget, so financial stability, and how do we attract patients, and more than that, attract the best clinical team and help retain that staff in our departments. And quality is a large area of focus right now. Quality is definitely part of the overall definition of what value is. When you look at value, it's quality over cost. And ultimately in our field, quality is quantified by outcomes and patient experience. And with us heading down this path of probably eventually a pay for performance model, what is that cost of achieving the overall value in what we're doing and the technology that we're using? And there is a lot of focus not only on quality but especially safety. And when you ask the question, why is that? We're in a healthcare system that many would say is broken. It was a huge point of emphasis in the most recent elections, and we're also operating in this sort of overarching feeling of fear with the sensational media articles that came out in the New York Times. With all of this change, uncertainty, it's tough to really look for ways that we don't get stuck in a state of paralysis and look for opportunities to get better. Now, when you look at radiation therapy as a whole, we all know that it's a top cost driver in oncology compared to surgery and chemotherapy. As a whole, radiation oncology, we're in a unique situation right now where we face decreases in payment rates, some would say up to 14%, depending on what publication or documentation you're looking at, and even what state you live in, apparently. We are experiencing a lot of micromanagement of the process with the third-party payers. We recently had an experience where the insurance company was dictating to us how many beam angles we could use for a plan. A lot of times we're having to call ahead and get pre-authorization for the plan that we're producing. So we do all this good work, and at the end of the day, there may be no guarantee of payment. And ultimately, it's expensive to not only to the providers, but also the payers and the families. And we're really kind of heading down this path of possibly a flat rate treatment. So regardless of the treatment plan you do, not seeing a huge overall substantial difference in the payment you receive. So in response to all of the quality and safety discussions and the New York Times articles, the experts in our field came up with this response through this publication, Safety is No Accident. And if you haven't had an opportunity to read this publication, it's very well done. The four key sections of which are laid out here. One of the focuses of this publication is this expansion in technology that we've experienced, which has led to increased complexity in everything that we do. And one of the quotes out of this publication specifically said, "Radiation therapy has never been simple, but it is now exceedingly complex." And that's really driven by the technology that we're using. And with that technology, you see driving down the highway all of these billboards advertising, if you come to our center, you're going to receive the best possible care that you can receive. And typically what drives that message a lot of times is the technology that's being used in that facility. And so we know it's a huge point of emphasis on not only what we do, but also in marketing. So with that technology, it has increased the complexity of the plan review and evolution process. So what makes a good plan? When you talk about benchmarking plan quality, with all of the recent evolution of technology, and it's brought all of these challenges. So not only are you looking at a prescription that's no longer a one-liner, it's almost a book of items that the physician wants you to achieve, both with target coverage and your critical structure constraints. You're driving that plan through a CT-based set of images, optimizing and calculating the plan, and then looking at all of these various things, including these crazy graphs that have all of these various parameters on it, and it's really tough to make heads or tails if you haven't been involved in the entire plan process, if this plan really is as good or optimal as it can be. So technology is definitely making things more and more challenging for us in doing our job. So what defines a good treatment plan? When we ask that question, historically it was following the physician prescription and beam parameters. In the 2D world, it was, having standardization was a little bit easier to quantify. With technology, it's brought enormous possibilities for us, for the patient, to be able to sculpt dose and doing a variety of great things to improve their overall quality of life. But also there's trade-offs with that. There's this expansion in technology has increased the limitations to accuracy. In other words, there's more variability with the output of what we do. 3D treatment planning is now very well established. As I said earlier, 2D planning, it emphasized geometric portals, and standardization was much, much easier to accomplish. Now 3D planning emphasizes a variety of things: contouring, not only the targets but the organs at risk. It introduces all of these various elements of heterogeneity and beam models and looking at our abilities to conform dose. IMRT has allowed us to do some great things, with sharp dose gradients and creating complex and a variety of shapes around the tumor. Essentially what it's done, though, is allowed us to escalate dose and sculpt that dose to increase the quality of life for the patient. And there's many trade-offs, some of which are listed here. Increased importance on immobilization and reproducibility on the machine, and having to spend more resources, time, to make sure that the plan is as good as it can possibly be. And there's a lot of great studies on all of these things and the benefits of all this advanced technology. However, the groundwork of these studies is really rooted in the assumption that all contours and treatment plans are built the same. And so this technology evolution has increased the quote-unquote artistry of an acceptable treatment plan. Now, this artistry is really why I love doing what I do in this field. It gives you the opportunity to explore different possibilities, and not every opportunity or challenge is going to be the same. So that challenge is definitely something that is a welcome thing by many people in this field. But it's tough when we look at trying to define what best practices are. When we look at opportunities for training, going to conferences and looking at publications, we're starting to ask the question of, should there be more? And ultimately, a lot of times we feel like this, where benchmarking plan quality feels a little bit like we're comparing apples to oranges with all of the various limitations and challenges that the technology has brought. So how do we correct that? How do we minimize variability? What we do a lot in our presentations and kind of our focus in this company is to look at what other industries have done in terms of minimizing variability. In this book called Good to Great, one of the things that this book did was looked at companies that are viewed as doing great work, retaining staff, financially stable, and essentially what they did was they looked at all of these great organizations and did a deep dive inside. What's inside this black box? What makes this company go beyond just being good? A lot of these companies have a huge technology focus, and the book even says you can't remain a laggard and hope to be great. I mean, there is certainly a focus on technology, but technology on its own is not going to create a transformation. It can definitely inspire one and accelerate one. No piece of technology on its own is going to do that. So optimizing human performance with the technology is essentially the theme of the book. So investment in people. What they found was that an investment in people, it pays much higher dividends than any investment in technology. And so one of the themes of the book was looking at the colleagues that were part of these organizations, and there was this feeling of ownership, not in a proprietary sense, but just ownership in the processes, not just having this feeling of this is my job, that's not my job, That's for someone else to do, having this renter mentality, but more of an ownership mentality. And so when we look at people in our departments, do we have that ownership mentality? One of the other focuses that we have a lot when we talk about quality is on this guy, W. Edwards Deming. And we'll go over a little bit later why all of his methods have been instrumental in other industries. But essentially, the message that we've been putting out there is that a lot of the philosophies that he has taught in manufacturing and the auto industry can apply to healthcare. And this was even mentioned in this most recent publication, The Safety is No Accident, that was published by the experts from Astro. There was a section in there that talked about the Toyota production system, you know, incorporating these ideas of Lean Six Sigma into our workflow to decrease waste, increase efficiency. A lot of the philosophies that the Toyota production system incorporates were actually taught by Deming and his colleagues, and there's a mention of this word Kaizen, which really means a change for the better, or a focus on continual improvement by constantly tweaking the system and looking for opportunities to get better. So when we look back at some of the studies that we've been looking at, we looked at the process of radiation oncology, and if you treat it like a manufacturing line and break it up into these different silos, the first of which being this contouring and anatomy delineation, and as this little cartoon kind of alludes to, one of the assumptions is that if you take an anatomy class that, you know, somehow that equates to best practices, and we know that that's not necessarily true, and we're not going to get into a detailed discussion on the publication here and some of the work that we've been doing with the contouring challenges, but really this idea of variability has been a key focus in terms of having professional treatment planners contour the same thing and then looking at the variability that exists. And that's typically what these graphs here are demonstrating. And so even though technology is important and has definitely improved some of the efficiency and the things that we're able to do on a daily basis, as I said before, technology has increased the variability overall, at least the opportunity for variability. I would say the same would be true for the treatment plan quality process, or that silo in the overall process. We have done some publications around this plan challenge idea where we gave a data set out and had planners from all over the world plan on these known set of parameters and common goals. And again, the end result was a high degree of variability in some of the results that we saw. And as I said before, there's some other forms that you can view if you're interested in more information on the overall results that we saw. But essentially we use this idea of a PQM, or a planned quality metric, which was incorporated a whole list of heavily weighted scoring criteria of common goals that would go into a typical IMRT plan. So if you looked at target coverage or organ at risk sparing, global max location, all of these things were incorporated into a total sum score, which we called a PQM score. And then through that score we were able to track the data. And so what these blue bars are really representing is that variability that we saw. So the data collected showed a wide distribution of results, and essentially what this is saying is that based on a known provided set of goals and criteria, there is that not every plan is built the same. And so here's an example of a variability curve before a continual improvement program would be implemented. Essentially the goal isn't to achieve the highest maximum score. The goal with any continual improvement program is just to drive that curve to the right, which means you have a higher mean performance, you're going to have less variability overall, and really when you break it down, you're going to have a better best and a better worst. And variability has a lot of different meanings in different technical fields, but for our purposes, really the definition of variability is what's achievable versus what the results are. So back to this idea of how can we minimize variability. It's one thing to present a problem, but what's the solution? if we look at these experts in the quality arena in other industries, as W. Edwards Deming demonstrated, before 1950, Japanese consumer goods had a reputation of being somewhat shoddy and cheap. And then 4 years later, they're producing products that were widely known as being better than what we were producing in the United States. And so how did they accomplish that? They essentially had over 400 engineers study in these intensive courses on statistical analysis and this idea of measuring quality for continual improvement. And in the book, Out of the Crisis, Deming states that innovation definitely can lead to improving the process. But one of the things that he focuses on is that new machinery and gadgets are not the sole answer to continual improvement. That these philosophies not only can apply in manufacturing, but can apply in service industries like healthcare. Now, we know in the daily grind it's not probably a practical thing to have to sit there and review every single structure that we contour, but what is practical is implementing a quality system that you could do on a quarterly basis or an annual basis that really can drive the point of minimizing variability, and that can have a huge impact on improving the overall quality, mitigating risk without a huge price tag. And this idea of statistical process control is really what Deming taught. Now, when we look at a common approach to problem solving as humans, we like to brainstorm different ideas, categorize those down, and analyze them, and then come up with a way to act. What Deming taught was that a quality improvement process should be continual. There's never an end point where you design a plan, you do that plan, you study the results in a measured way or quantitatively, and then try to determine ways to improve upon the initial results. This is opposed to the wrong way of a similar program that I use when I'm doing housework, which is to guess how it should be done, do it, and then it blows up in my face, and then figure out a way to fix it. And so by incorporating some of these elements that Deming taught, we can relate this back to this recent publication that just came out from Astro. And one of the things they talked about in this publication was the importance of having an intimate relationship with the vendors and the end user that's using that technology. But we see a breakdown a lot with these, because the products come out so fast and the technology is sometimes hard to keep up with. There's a breakdown in the education and the training, and as this publication alluded to, many times these training programs are rarely available. But I like this last statement that they made in here, which said, nevertheless, centers must ensure that providers are qualified to deliver any care. So this kind of goes back to that pay-for-performance model. And in the publication, they go through and they lay out what a good quality system may look like. And one of the things that they state is, as important as accreditation and things like that are, and having this focus on improved policies and procedures, relying on those things for a continuous improvement program typically is the least effective approach. So what is the answer? The answer really, as Deming stated a lot, was this idea of measurement. What gets measured gets improved. A measurement and transparency can drive accountability. Some of these quotes came out of this book called Results That Last from Quint Studer, and it can be used as a diagnostic and process improvement tool. And that's essentially how we built this ROQS program. It operates in this plan, do, study, act mindset and we've changed the verbiage a little bit, which is having a metric-based assessment, doing objective benchmarking, having a personalized learning program, and then measuring that improvement. And that is essentially ROQS. So at the first step, this metric-based assessment, essentially we give a set of common goals and parameters through the metrics and having a PQM score provided through those metrics. We give a prescription out with, we have a variety of data sets and body sites that are clinically relevant that you can choose from. Again, all of this is driven online through the web. And once we collect those plans, we do the second step is this objective benchmarking phase, where we look at the dose distribution, and all of the things that are common with the plan evaluation process. But more than that, we're able to use that PQM mindset and look at opportunities for benchmarking, providing those results with a nice multi-page report. And beyond that, this third step is really the unique feature of this program. You'll be given a list of not only strengths but potential areas of improvement with a login and password to a video library where you can, depending on what planning system you're using and what body site you participated in, you'll have a customized video to watch just based on some of the things that we've learned through the process going through it ourselves on how to improve the initial scores. And that's, again, the foundation of the continual improvement process. And then the fourth and last step is this idea of measured improvement. So based on the initial results and the customized video library, looking at opportunities for measured improvement, or just really a validation of your of the good score that you initially achieved. Regardless, MDCB credits will be given through this program, and so there's a lot of value in going through that. And this would be a typical cover page of a report that you would receive. As I mentioned, it's several pages of a very specific drill down analysis of every piece of the program. And the contouring piece behaves very similar to the planning process. One of the questions that we get asked a lot is, where do you get your gold contours or consensus contours? Now, the ROQS contour program, we can use a variety of different gold contours. The ones that we use, if you opt to use ours, were driven by, and this publication kind of lays it out, a physician-based contouring challenge where we had them contour on these data sets, and then we used a software program to develop the gold or consensus contour that is being compared against. Regardless, this quality system it contains 6 regions of the body: the head, neck, brain, thorax, GI, GU, and GYN. Organs at risk are assigned. The initial results are measured in a quantitative way, and then there is a login and password to a training library where you can look for potential areas of improvement. And then once you've gone through the video library, you can redo the contour if you need to, and then receive a brand new report. We use a software program from Standard Imaging called Structure, where we bring in those DICOM files, and then based on the missing or extra voxels, you'll receive a score, which we've coined a CQM, or contour quality metric score. Now, it's one thing to receive a score, but really the value is also having that score provided in a performance record based on how others were able to do on that same structure. So that was an example of a database of contours we've collected from a seminal vesicle, let's say, from one clinic. And all the things that are common to the challenges of contouring we've seen through this program, and it's helped us not only within our own company see continuous improvement, but also with the clinics that we've been involved with. And so various things that are challenging on a daily basis would be, contouring things like the prostate or the rectum, and how you define those things. So communication is huge. And also, in addition to communication, one of the things that we found through this program is one of the breakdowns in any sometimes in a department will be just the way that we name our structures. And this publication here I thought was pretty interesting in terms of something as simple as coming up with a consensus for naming our structures consistently will eliminate communication breakdowns and ultimately variability in the process. And so they lay out recommendations for how we should all be contouring a structure. And I think probably as the next year or two go by, we'll probably as an industry be going down the direction of all naming our structures exactly the same way. This is an example of something that you wouldn't think would be a variable structure, like the femoral head. And we've run this process through departments where they have multiple people involved in the contouring process and seen variability with structures that you wouldn't think would have variability. And this variability was made clear through going through the ROQS program. Essentially, it came down to just a breakdown in communication. Again, where do we stop that inferior aspect of something as many would view as simple as contouring a femoral head? And really the ultimate goal is consistency and absolute best patient outcomes and predictability, and that's what any good quality system can help do, is define those standards. So regardless if you believe our gold contours are an absolute, I think everyone can agree on the fact that variability can and should be measured. And so having this dialogue about how we should name our structures or how we should contour them as a clinic or an institution or a network of clinics or a community of professionals is a good thing to do. And so through a program like this, one of the things that can happen is, as this graph demonstrates, the blue bars on top were the initial results of contouring, in this case the prostate. And then by going through a continuous improvement program where you're measuring the initial results and then talking about the breakdowns and then going through a training intervention, whether that's video based or whatever, the red bars would then demonstrate that measured improvement. And that's what's demonstrated here on the bottom for not only for that structure but also the brain stem. And we've seen similar things, especially with smaller structures that may be difficult to contour. Just having the opportunity to do an initial run through and then talk about the breakdowns and areas of strength and coming together as a team, seeing a significant reduction in variability. So the ROQS program also has a planning component, and this mantra kind of has inspired this piece of the program, and really we built it with the idea of going from what's achievable more to what's possible. And this was illustrated in this publication from UCLA, where they talked about looking at not just what national standards are currently at, but trying to come up with their own way of doing things to really tighten up the criteria and going beyond what's just considered acceptable now, but going to what's achievable. So this ROQS plan part of the program has 6 body sites currently, from head to toe: lung, abdomen, brain, head and neck, GYN, and male pelvis. And as I mentioned earlier, it operates with this idea of a PQM, or plan quality metric, that involves very common clinical goals with an associated score. And then through that score, we're able to break down each of these common clinical constraints that you may see in the IMRT process, like target coverage. And if you have your 95% volume on a target, you'll get an associated score. Same thing would be true for the organs at risk, like the mean dose for a parotid or the global max location. So all these things would get an associated point score. And don't let the PQM metaphor confuse you. It really just incorporates all of these things that we commonly do when looking at our plans, going to the DVH and measuring volume at a dose. But one of the neat things with this program is we can incorporate some really valuable indices and metrics that are in these publications that may not be used on a practical basis every day. And that's unfortunate. Things like the inhomogeneity index or the homogeneity index, which is these tools are very valuable. The RTOG has this conformality index. It's in several publications where you're looking at the total volume of your target covered by the dose that's been assigned. We'll talk about conformality index versus confirmation number, but the neat thing about doing a program like this is we can not only do the assessment and the video library and you get this nice report, but we can talk about some of those other indices and metrics through the program and kind of break them down on a more practical level and give you an idea of how they can be useful on a daily basis. An important element of the ROQS Plan program is the software that we use, and it really is the bedrock of being able to allow us to do what we do. And the software has components in it that are familiar that any treatment planning system would be able to do, looking at the beam parameters, the dose distribution, the DVH. But one of the unique things about the software is the ability to do a quick performance record. So based on the goals that were originally assigned, looking at areas in green, which would be areas of strength, and then areas in red or orange that would be potential areas of improvement, and then logging that score in a performance record so that you have a good idea of not only what your score was, but where it was in relation to how others were doing. And we can look at very common things like target coverage and organ at risk sparing, but dose bleed off, and evaluate some of those things. A lot of people have asked us, well, where do you get all of your metrics from? And of course, each body site's a little bit different. We wanted to create them to be clinically challenging, to go beyond what may be deemed acceptable in some of the publications. We were definitely inspired by things like this, these Quantec numbers, and so each body site is unique. We try to make it as clinically relevant as possible. One of the nice things with the program is we can talk about not just the standard things that are out there, but some of the more complicated and fine-tuning elements that go into a treatment plan, things like bone marrow sparing for GYN IMRT, or looking at for a prostate case, looking at low-dose rectal sparing, and how we achieve some of those things. So not just looking at target coverage and max dose on certain structures, but really trying to drive that dose in ways that you may have not thought possible before. Looking at things like lip sparing for head and neck IMRT. A lot of times, in the traditional planning process years ago, we weren't concerned about things like this. Well, with all the multiple beam angles and the various real estate that we're now taking up in the patient with throwing the dose in, it's important to evaluate areas that years ago we didn't even consider evaluating. So just talking about some of these important elements in the planning process, through ROQS we're able to better refine our skills and have some great conversations about some of these things. So the takeaway really is one of the end goals, as I mentioned earlier, is to not be talking about treatment plans where on the same set of parameters we're looking at all this variability and having this feeling of comparing apples to oranges, really getting down to the end state goal of having our plans be truly apple to apple. One of the things that we discovered through this program is we're now practically using things like confirmation number, these great indices that are published that I think unfortunately a lot of times get overlooked in the daily process of reviewing our plans because there's so much to do in such a short amount of time. But these tools can definitely be useful, and they're more useful when there's a better understanding of what they're intended to do. We ran some various studies and logged low versus high confirmation number, and what we saw was this was a abdominal IMRT plan, and with the same set of parameters you can see a drastic difference. This is the dose threshold was set at the same amount, and when you compare the two plans side by side, you can tell that there's definitely a less conformality with the plan on the left versus the plan on the right. But we then linked this back to that confirmation number, and sure enough, the low confirmation number was that plan on the left. And so being able to use software and a program like this to infuse some of these great published metrics into our daily plan review process is another potential result of going through the ROQS program. So what we've learned by building this program and delivering this program is that communication is definitely crucial. Deciding on common priority weights is definitely challenging, but going through a program like this can help establish what guidelines and protocols may be most beneficial to you, or ones that your physician would prefer using. And we like to always go with this idea of being a lifelong student. I think it's unfortunate sometimes we hear that people hang their hat on years of experience or being certified, that I don't need to be in a peer review process, I don't need to be involved in a program like this. And we've learned so many things from dosimetrists or treatment planners that may not have been in the industry as long as we have. And by going through a program like this, it really stresses the point of being a lifelong student, and ultimately who benefits from that is the patient. Some other benefits of the ROQS program: we've seen others use this for annual competency reviews. You could use a quality system approach to test new treatment procedures. If you're an experienced dosimetrist and you've jumped onto a new treatment planning system, we can help define where you were at on the treatment planning system you were most comfortable with versus the one that you're currently using. We have access to all the major vendor platforms through this program and can provide relevant information for any of those. You could test new colleagues. If we just recently have hired some new individuals, and this is not meant to be a negative thing. It's meant to be a positive part of going through a continual improvement program where you do an assessment. We believe the initial run through, there is no wrong score. It's just an opportunity to get better. And by using a program like this, you can help facilitate that. And last but not least, being able to obtain continuing education credits is a part of this program as well. And so the end state goal really for us as a company and through the program is to, as I said, decrease variability, have scores that may have been at or below the mean, and drive those to the right and really measure that improvement. And that, in a nutshell, is our ROQS program. As this book, Good to Great, says, and we talked a lot about this at the beginning of the presentation, that technology can't be the main focus of a quality system. It can definitely help accelerate a transformation, but it's never going to be the sole cause of one. And by establishing a quality system like ROQS, for some key elements of the radiation oncology process, like contouring and treatment planning, through testing, training, sharing best practices, we can establish a continual improvement program, and ultimately we're investing in the one thing that matters, which is us. I mentioned briefly the software that we use to do the ROQS plan part of our program, and this software program will be commercial in January. It's called Quality Reports. We have some information on our website. It was developed by Dr. Ben Nelms. We'll be distributing the product. It'll be available in January. Essentially, the software program, you could use it for your everyday clinical plan to load the DICOM data, select a quality metric template that you've designed ahead of time, and then track the performance records of the plans that you're doing into your EMR system. And through this, you can really develop maximum efficiency and consistency across the board. We really believe if it's important, you should track the metrics, and that's really what the software is designed to do. And as I said, there's more information about this software program on our website. If you have other questions, you can call us, and we'll be happy to answer those as well. And again, one of the key elements of it is to remove variability, regardless of what planning system you may be using or machine you may be using. You can, if you have various sites that are using different planning systems, you can use this software to help be a common software funnel. I appreciate your time and attention in this presentation. If you have any other questions, feel free to contact us here. And we look forward to talking to you soon. Thanks again.